All right, so how do you prove that two functions are actually inverses of each other? So what you do is you take one of them and put it in for the x into the other equation. And remember, if it's an inverse, everything just undoes each other. So when you undo the whole thing here, when you're done doing that, if it's correct and done as a true inverse, what you'll get afterwards is just a plain x. And then you turn around and you do it the other way. So you take this whole thing and you put it in for just that x right there and see if everything, all the operations undo each other. And in notation, what that looks like is this. Remember in these dot notation, what that really means is f inverse of f of x. So this one is saying I'm putting the f of x formula in place of x in the inverse. And then this one is saying I'm going to put the inverse formula in place of x in the f formula. So that's the correct notation. And then we're going to see if select the correct below, fill in the answer boxes. These better be x's if they are truly inverses of each other. So let's see. If it's an inverse here, I'm going to first do the blue markings up here. In place of this x, I'm putting the cubed root of x plus 8. In place of this x, so then this whole thing's cubed. And then I've got a minus 8 outside of it. So doing that one, to do that one, what is this cubed do to the cubed root? And hopefully you tell me it undoes it. It's the inverse operation, so it takes it off from there. So the only thing I have left here is the plain x plus 8. And then take away this 8. They undo each other, so all I have is x. So that was this first one, so that's good. That's what we wanted. I'd put an x in that box. And for the other one, where I was going, let's say, I think that's the one I did, putting the f formula, no, I did it the other way around. I put the f in the inverse formula into f, and that would be this one. So I just did that one right there. Now let's do the other one, where I'm going to take the f formula, my f formula right here, the one I wrote in pink, and put it into, see how my f formula is being put into the inverse formula? So let's see how that one ends up working out. My f formula was the x cubed minus 8. Put it in place of this x, so I've got a cubed root and then a plus 8. This part right here is replacing this x, but I still have a plus 8 outside of it. So then what do these two are going to undo each other to start with? And then I just have my cubed root. That'd be better if that cube was inside of that little hook in the front. Like this, and the cubed root undoes the cubed. So then I just get x for that as well. So yes, they did both prove to undo each other, and that's how you know when it's an inverse.